Okay, welcome back everybody. Now we're going to look at a slightly different situation. I actually had to use a different sensor to get this to work. So this is actually bouncing a sound signal off of here. Sometimes it gives a little bit more static, but it'll give should give us a new type of graph. Okay, what we're going to look at now is we know that the position over time graph moves away, and we get as the cart moves away, we get a nice positive slope. Now we're going to compare that to a velocity over time graph. It's something moving with constant speed, and see what happens there. All right, so here we go. Okay, there's our motion, pretty constant. And now we're going to look at the graph. Okay, now again, just like before, kind of got to disregard that first part of the graph because that's before it was moving. Now notice here, this is actually kind of interesting if we think about it. When it's not moving, it's just a flat line, okay, a horizontal line. That shows basically it's staying at a certain position and not changing, okay? Over here on this velocity versus time graph, that shows as a zero velocity because it's not moving. Then very quickly it goes to some velocity right here. That's what this is showing, basically going from zero velocity to some velocity. And then once it hits this velocity, with the exception of just a little bump, which is just some static in the signal, it's nice and straight, okay? What that means is that I'm staying at a constant velocity. You can think about that as a constant speed and a constant direction, okay, where it's moving and not changing that velocity. So it's recorded here where we have a velocity over time graph. It looks actually identical to a position over time graph when things are staying still, okay, where it's got some value, it's just not changing. Here it's got some value of velocity, it's just not changing, okay. In this position over time, constant slope. Right here, velocity over time, constant horizontal line, showing that constant speed in a constant direction. Okay, we're going to look at one more graph that is just moving in the opposite direction with the velocity graph. How do you think the velocity graph will compare when we look at it going the other direction?